Yo, yo, yo. What's up? What's up? Welcome back. Today we're working on an intro screen for stream because what we had there was not great. And I think we're going to be working with freetype and OpenGL. The idea being that I want like some sort of animated thing, right? I want it to like kind of like count down or something. And so to do that, I need to like draw something on the screen, and I'm just like, hey, OpenGL draws stuff on the screen. Uh, it turns out that like there's a reason that a lot of the streams I see have these like stream starting messages coming up like when they start. And the big one, I think, as far as I'm concerned, is I found out that like Twitch forces pre-roll ads on your stream. So when somebody clicks on your stream, they get like ads, unless you run 3 minutes of ads per hour. And so by like running a 3 minute ad before you start your stream, you can kind of like force pre-rolls to turn off for the next hour, which is pretty sick. Because like when I'm browsing Twitch and I hit like 3 pre-roll streams in a row, I just alt F4. It like pisses me off so much. So I'd rather not have those there. So in order to like not have anything of like importance missed, stream intro screen, cool. And so what I was kind of thinking is that like since this is like a coding stream, it would be kind of fun if it said like, we had like stream starting in, and then like maybe it like says how long, and maybe like as it's decreasing, it would like look like somebody's typing in like the time, right? So like, and when it rolls over, they like type in like 49, whatever. And so I was thinking it would be kind of fun to try to figure out how to make something like that work. I don't know if it would end up looking good. I don't really know until we try it. And I also don't know how someone would normally go about doing that. I assume that like people who are good with video stuff would use some sort of like Adobe Suite program to make something like that. But we're programmers here, and so we're gonna program it. And so I'm gonna make like we're gonna like start up like an OpenGL application that essentially does this. Writing your own OpenGL, or you're gonna use something like Godot. So I was considering using like a game engine or something, but it feels like what I'm doing is so simple that it should be able to be done with OpenGL. And we like to fully embrace not invented here syndrome on this stream. So more fun to write it from scratch. And I kind of like generally take the approach of try the like least like the most involved, least dependency thing until you find out that there's a reason that you shouldn't, right? So I don't actually know how difficult it is to get all of this working, and so I just kind of wanted to try just for the experience. Maybe we'll find out that there's a real reason that I should be using a game engine for something like this, and yeah, we'll find out. So rough plan of action is try to like get an OpenGL window. There's a lot of like pain in the ass setup stuff that happens when you write an OpenGL application. So the like getting a triangle rendered on the screen is like that's like a pretty big milestone. Then we can start like trying to render out like some colors, make sure we understand our like coordinate systems, get like an image loaded, then start trying to do work on like text rendering, and then hopefully we'll get to somewhere interesting by the end of it. So let's start moving. So I did cheat a little bit because this like OpenGL stuff is like a massive pain in the ass a lot of the time. Like there's like a lot of like finicky things that you kind of have to get out of the way. So I did a little bit of like a refresher for myself yesterday because it's been like a few months since I've worked with OpenGL at all, and so I kind of forgot some of the intricacies. So I did yesterday quickly bang out an application that showed an image on screen just to prove that like I knew how. So some of this stuff I'm going to be leveraging information from yesterday. But yeah, so just keep in mind this isn't like the first time I've done this when you're watching. If you're like, whoa, how the fuck did you get there so quick? That's how. So let's make a little window for it. So, or sorry, a little folder for it. So we'll say like stream start screen or something. And this is gonna be like a Rust application. We need to pull in some dependencies. So I'm just gonna copy paste my shell from the stream operating system working on, and maybe delete a couple things that we don't need in here. That's really it. Rust up. Sure. Maybe that's it. We'll see. I was like browsing window. Okay, so if I understand correctly, which I might not, I think that you have like in order to like start up an OpenGL application, I think that there's like my window manager over here, window manager, and when I was looking at like what you need to do to get like an OpenGL surface to render on, first you need to like create a window, which is done with like through either like Wayland or X. So we'll say like X, we'll say X or Wayland. He creates a window, and usually there's some sort of library that will do that. Then you need like to get an OpenGL context, OpenGL, and he needs to like bind that context to the window. And then we need to like get like OpenGL functions. So I don't really understand exactly why, but I've seen like often people use like OpenGL bindings generators. I don't really understand why. But basically, like the OpenGL is kind of like a protocol, I think. Like it's like a set of functions that are like guaranteed to exist, and you might have like extra functions that are like extensions. And so maybe you like instead of this guy's saying functions are dynamically loaded with DL open. Yeah, so I guess depending on the driver, you might end up having functions that exist or don't exist. So it might make sense to like generate bindings at runtime to like figure out, I guess, what like do the probing for you. Anyways, there's like a lot of different driver stacks, or like I shouldn't say driver stacks, like library stacks to do this. The one that I was like Googling that's like most common in Rust is to use like Winit and Gluten. But when I was like trying to use those yesterday, I was like, holy fuck, this is like complicated and a pain in the ass. And what I've used in like C++ land in the past is library GLFW, or in Python land I've used the same thing. And this example is simple as fuck. So I'm starting here, and we can always swap out this layer and this layer later if we want to. So let's just start there by getting a window up and running. So I just need to cargo init, make a new binary. Add glfw to our dependencies. I'm seeing a glfw in chat, glfw lol. So I wonder if there's a reason that is this like a bad library? Am I a fucking noob for using this? Very possibly, but it is what it is. So we build, we get glfw. Let's see, cmake not installed, so we just need to update our environment a little bit. Throw a little cmake in there. Cargo build. What's it bitching about now? I'm probably just missing a bunch of stuff. Let's how do I want to do this? I think I've done some like GUI applications before with my hold on, I had another thing that we did recently, the keyboard overlay, and maybe that's a better starting point. So we called this fdev test, and in here there's a shell. Yeah, this is probably a better starting point for a GUI app. I can help you with gluten if you want. Well, I'll probably not worry about that for now, but I probably will upgrade at some point off stream. But I'm not really too worried about it. So we'll remove shell. Which one of these is the good one? So we'll remove this other environment. We'll say this guy is the one we actually want. And let's just double check what's in him. He's got a bunch of extra stuff that we probably don't need, but that's okay. This is like a good starting point. Next shell. Cargo run. So hopefully this time it actually builds. Hopefully this time it actually runs. Cool. So we got a little hello world in there. We didn't actually try to make our glfw window, so let's just quickly bang that guy out. Copy paste the example. Cargo run. Okay, so we have our window now. Oh, cool. He's like logging like that stuff. That's neat. And so what does this guy actually do? So what What is fail on errors? Oh, okay, I see. So here they're saying initialize. If you initialize and you fail, I assume this macro does something like panic. Yeah, he panics if there's an error that comes out. That's fine. I guess this is just like an error callback that they call, okay? And then they unwrap. They create a window of size 300 by 300 in windowed mode. That's reasonable. This is a way to like, if I remember correctly, there's like this like make context current call that you have to call in OpenGL code to say essentially like, when you OpenGL is like a very like stateful API. You basically just say like you just like write draw, and where it draws to depends on a bunch of things, and one of those things is like what window context you're running in. So you might have like an application that has 2 windows, and you might like set each individual window as like the current context. Something to do with like keyboard polling, and then here's our like a little event loop. So every frame they swap buffers, and then they poll for events, and then they like do something based off the events. Cool. Okay, so we've got a window, but we also need like OpenGL APIs. So we'll say get OpenGL bindings or APIs. And what I've used here in the past is this like library Glow, which I think stands for GL on whatever. I'm not sure if this is like the best OpenGL bindings for Rust, but you know, it works. It's what eGUI uses, so that's where I ended up. And I think I wanted to pull in their like example. Glow GitHub Rust. And in here, we can just kind of pull out, they have like an example here that runs on a couple different backends. They like they initialize with SDL or Gluten or WebAssembly, whatever. So we'll kind of like just skip all of that, and we'll pull in like the actual code that they use to start up. So we'll just pull in their example here. So this is like initialization shit. We can quickly run through it. So they create a vertex array, which is like basically a definition of okay, I gotta be careful here. There's vertex buffers and vertex arrays. If I remember correctly, vertex arrays are like definitions of which vertex buffers exist and with what configurations. And vertex buffers are like lists of numbers essentially. So you can imagine like if you like were to like open Blender and you were to like try to render like let's pull up something more interesting. I think you'd like try to render like Suzanne, they call this monkey. You might like create a vertex buffer that is like a list of all of the individual vertices on this guy in like a specific order, so that you can say like, oh, these 4 in a row will make a face together. And you might like bind them as like 1, 2, 3, 4, then 1, 2, 3, 4, 1, 2, 3, 4. And then, yeah, so vertex buffers, like you would like upload all of those to the GPU. And so that's kind of what like this concept is supposed to be. They're kind of embedding some vertices directly into their vertex shaders, which we'll maybe explain in a little bit. But that's kind of probably what they're doing here. They're creating a program. So if I remember correctly, again, prefixing in general, I'm kind of like making stuff up and matching my mental model to what I observe. And like if my mental model is wrong, but it works well enough for me, I might think something that's like just incorrect. But my understanding of like these like programs is that you write like this like generic shader code, they call it, where shaders are like, as far as I'm concerned, like a bad leftover name from early days of GPU programming, where shader kind of means run code on GPU. And they have this like compiled C-ish language, but depending on like what GPU you have, it might compile differently. It's going to compile in just like some sort of like low-level thing for your GPU, I think, or maybe for like your GPU family or something. And so what like applications will do is they'll like embed the source code for a shader, and then they compile it for your GPU when your program starts. And so here they're like essentially doing that. And then they create a program from these like 2 sets of shaders. They just have like a vertex shader and a fragment shader. They run back to back. The vertex shader is in control of like, if I'm like looking at this monkey in Blender, the monkey, let's say it hits like canonical definition is to like, this is the monkey. Like my vertex is like here from this point of view. And if I like rotate the camera around, all of a sudden like all of the vertices for the monkey, they have to move, but like where they are relative to each other doesn't move, if that makes sense. So like the vertex shader, you would generally use that to say like, oh, when I rotate the camera, I'm going to apply some sort of like constant transformation to every single one of these vertices. And if you were to do that on the CPU, you'd have to iterate over every single one and do some math on it and be like slow as fuck. So they have these like vertex shaders, which basically say like, run a transformation on every vertex at the same time in parallel on the GPU, because the GPUs are like really good at doing lots of stuff at the same time. So that's like the vertex shader. Then they throw out in a fragment shader on the back of it, which is like, if I were to like color in some of these vertices, right? If I were to like go into like, oh, please don't crash. Right, like say that I want to like change the color of my monkey. Can I do that this way? Oh, is that the world? Yeah, here. If I want to do it on the monkey, I might like, you know, say I want to like make her pink. The fragment shader, I think, is basically for each face that is drawn. They're going to run the fragment shader for every pixel that's visible on that face. So you run the vertex shader to like say what's visible, where are my vertices, stuff like that, and then the fragment shader will say, okay, now for each thing on there, I'm going to color it something. So here they're saying, and it will like interpolate between the different points on your like in here. If I were to like draw this face here, it will like, even though I only have 4 vertices here, it will like interpolate so that I get every single pixel in here with a location relative to all of the pixels or all of the different vertices, I guess. So that's what they're doing here, is they're saying, hey, we're gonna make a color that's some form of function of where I am on my triangle. Probably this is like red, green, and they're just setting blue to 0.5 no matter what. And they compile this program. This is like them. I think they're compiling it here, linking it, and then deleting the source code stuff because they don't need it anymore. They've already compiled the program. Here they're saying, please use this program. You might have like tons of different programs for different things that you're rendering, right? If you're rendering the monkey with like one set of materials, you might actually want to render a different object with a different set of materials. So you'll have different programs that you like bind and unbind for different contexts. Here they're saying when you reset the view, use this color as the background. Cool. And then I assume somewhere in here they're actually doing some drawing. So here they have their gluten event loop, their SDL event loop, and I guess here they're doing GL clear and GL draw arrays. That's really the important part here. So every frame, we want to clear the screen and draw our triangles. And this is essentially saying like, draw the there are vertexes uploaded in the shader, and please interpret these vertices as sets of triangles, and please look at 3 vertices, I think is what this is saying. I'll have to we'll double check that later. We're missing, so in there we need to get some of their initialization codes, so we'll just copy paste the gluten one and then adapt it, because they're missing the initialization. So here we'll just say, instead of creating the window, we'll pretend that that part's already done. So anything window related, we can just delete. And then they need to create their GL handle, which is this guy. And I think they're also using the shader version here. So we'll just say let shader version is equal to version 410. I've always used 330. I don't know if I'm missing something in the new OpenGLs. Or GLSL's versions, which is like the shader language. They're kind of tied together, I think, if I remember correctly. But we'll see. Okay, now we're missing the glow dependency, so let's pull that guy in really quick. Boom, 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 and let's look at glow on docsrs. 0.13.0. Okay, and if I cargo build, let's just cross our fingers, hope for the best. We're missing this use here, so we'll just kind of throw that somewhere. cargo build. And they're saying that a lot of these guys are unsafe functions. So we'll just kind of slap an unsafe here, call it unsafe main. We could try to be a little bit more clever about this and like scope in where our unsafes are used, but I would bet that probably most of the OpenGL API is marked as unsafe, because there's a lot of ways to misuse OpenGL and like crash and stuff. So that's probably why they've done it that way. Just a guess though. So we'll make our main function and we'll just say unsafe main. All right, cargo build. We build, cargo run. Sick, very nice. Okay, so it's not like handling like window resize events correctly, but we are seeing a triangle, which is pretty sick. Okay. So what we're doing is we are working with maybe like, how do I say this? OpenGL is like a 3D API, right? Like here we were talking about like how you have like 3D vertices and you rotate the camera around and those get like transformed by the vertex shader. I don't think you can actually crash anything with OpenGL unless it's a driver bug. I've hit lots of driver bugs. I'll just tell you that I've misused the APIs and crashed a lot. Whether or not that's a bug in the driver or not, or like in the OpenGL implementation, whatever, I just know that I'm like hitting those all the time. But a lot of functions propagate errors. Yeah, I've also seen that you're supposed to call GL error a lot after like every call to like double check if there is a problem in there. But anyways, we'll see. Sorry, what was I gonna say? Right. So OpenGL is like a 3D API. And we were saying earlier how like our fragment shader is going to basically run for each pixel that you see in a face that you render. And so what we want to do is if we're going to do something like put an image on the screen, what we actually are going to do is we're going to like make a plane, have this plane fill up our field of view or orthographically, which just means like without perspective, and then we'll draw our picture on this plane, and this plane just happens to be the full field of view. So if I remember correctly, the way to do that is these guys have like a list of vertices here that they're going to draw, and this is like 3 vertices for that triangle that we saw on screen, right? We're going to run, we see this triangle, and I want this to have one quad that fills the screen, so we can say we're going to have 4 vertices now, and we're going to carefully craft them. We can ask OpenGL to draw what they call a triangle strip. So I'm like, the idea is here, I'm going to have 4 vertices, 1, 2, 3, 4, and I'm going to draw, which we're going to turn into 2 triangles. This triangle and this triangle. And the idea is, if I put them in the right order, 0, 1, 2, 3, if I ask for a triangle strip, what it will essentially do is it will draw 0, 1, 2 as one triangle, then 1, 2, 3 as another triangle. And the idea behind that is that you can like create like a curve, right, like this, and if you just like put your vertices in the right order, this will get like, I think they call it tessellated, triangulated, like this, and like this is a strip of triangles. And so we're just going to throw a 4th one on here, and we're just going to be careful about the order here. So we're going to start 0, 0, then we're going to go to 0, 1, then we're going to go to 1, 0, and then we're going to go to 1, 1. And then we have to update this guy to say a triangle strip, and with 4 vertices instead of 3. And I think here we should see a square now. Sick. Our square is not taking up the full field of view even before resize. So if I remember correctly, that's because OpenGL coordinates are from -1 to 1, not 0 to 1, like I just wrote. So if I just replace all my zeros with -1.0 and then run it again, I think we should get no. I thought that it was -1 to 1. Am I high? Oh, oops. This guy's doing some extra transformations on these guys. Yeah, I think that should do it. Cool. Cool. I just wire up GL debug stuff and log errors, use debug context for dev stuff. Oh, I always forget to do the debug stuff initially, and it always makes my life so much fucking harder, because like I just like end up guessing what the errors are instead of actually reading them like a smart person. So good eye. There's something that's definitely nicer with the newer GFX APIs. The debug validation layers are integrated much better. Sick, sick. Okay. So I guess what I want to do now is I want to make sure that I understand the colors. So if I remember correctly, our fragment shader here, he's having an input that is like a vertex. So here, this guy says I have an output that's a vertex. The fragment shader can like forward data, or sorry, the vertex shader can like forward data to the fragment shader. And so here he's forwarding like the 2D vertex position. And then that's getting interpolated. So I think that here, if I say I want my output color to be, you know, X, Y, and then 0, we should see like red in one corner, yellow in the other corner, green in another color, and black in the last corner, I think. And this is not what I expected to see. I was expecting to see black down here. And, oh, that's probably because the coordinate space of colors is in 0 to 1, but our vertices are -1 to 1. So here we just have to do some quick math where we say, can I reuse the same value? Can I do like, or is everything constant GLSL? I'm not actually sure. If I do like vert equals vert times or plus 1 divided by 2 to basically move -1 to 0 and keep 1 at the same spot, I think that works. No, he doesn't like that. Reassignment to read-only variable. So I guess we need to say float normalized vert, I guess we'll call it. And this isn't a float, this is a vec2, 2D vector. And we'll just replace this with normalized vert. Nope. Cannot construct vec4 from non-numeric data type. What am I missing? What am I missing? Is it this? If I comment that out, does it run? Yeah, okay, so... this should be a 2D vector. I should be able to look at X and Y here, but it doesn't like that. Normalized typo? Oh, good call, yeah. I assumed that it would give me a better error than that, but it did not. Okay, perfect. So this is what I expected to see. Yeah, black in the corner, yellow on the top. So it's kind of interesting. You can see here that like if we're using like linear interpolation here, you don't see like what like a human would consider linear dark to light, which is something to consider when you're writing this stuff. I think that you're supposed to use like, what is it? sRGB curve. Like there's like some sort of like mapping from like linear color space and how it's represented in the computer to like what you as a human want represented in your eyeballs. And then there's like some sort of like historic thing about like gamma and CRTs where initially our monitors didn't display colors how they like linearly. They displayed them with this like inverse gamma curve or something. So then we had to like apply a gamma curve to offset that, and then like all of our monitors for the rest of time had to like mimic the CRT interface. So there's something like that. I don't really understand it. Color stuff's hard. Every time I Google this stuff, I just get like really fucking lost. So, and then there's also something about like how the gamma curve is actually like what the CRT did was actually like happen to correlate well with what our eyes want. So like nobody noticed. I don't know. There's a lot of stuff in there. Colors are hard. It's essentially what I'm trying to say there. And I'm just not gonna worry about it right now. But just as an aside. Okay. So we've rendered a quad with colors. And I put the wrong time in here. Fuck. So there's like 2 timestamps that are sitting on my on my OBS. One of them is like the time that I started the stream. One of them is when I started the recording. So I keep getting them wrong. I have to get better at that. But we're at like 29:40, and we are going to try to load an image and render that. So I don't know. Can we just look like test picture? This looks like something interesting. So I'm gonna save this guy. I'm gonna try to load him into our OpenGL window just to make sure I understand how to do that. And the reason I want to do that first before getting into like font stuff is because as far as I can tell, the way people render fonts in OpenGL, I kind of like skimmed this. Why is there a fucking video in the middle about Batman actors in the middle of this fucking page about rendering fonts? God, I hate ads. Okay, but as far as I can tell, this like freetype API, what they normally do is they render individual pictures of characters, and then they stitch those together back to back. And so I want to make sure that I can display picture so that I get past the like that part of OpenGL before I get stuck on are my characters rendering correctly. So did I download that picture already? I can't remember. Downloads. USB. No, I did not download it, or it didn't write down. So let's just go back here. Save image as. This is called a glyph atlas usually, if I got you right. Okay, that is what I'm looking for. Where atlas? Why is it called an atlas? Oh, because I guess texture atlas is an image containing multiple smaller images, usually packed together to reduce overall dimensions. Oh, I see. Oh, that's pretty cool. So this isn't what I was gonna do. I wasn't gonna try to stick them all onto one image. I was going to render each one separately and then keep a like dictionary of characters to bitmap mappings. But we're getting ahead of ourselves. Let's start by loading any picture. But maybe we'll load one of these because these are kind of more relevant. Ah, fuck it. Ew. I don't like what they did to this guy's head. I know this is how you texture stuff usually, but that's gross, man. That looks really nasty. Okay. Where were we? We downloaded a picture. And the first image is more how it looks. Yeah, but I guess it depends on I mean, this is a similar concept, right? Where like when you like texture unwrap, you basically like map the faces into like a 2D plane and like put them wherever. But yeah, this is more what you were talking about, I guess, with like I guess it's like with sprite sheets are probably the same thing. Oh yeah, also called sprite sheet. Yeah. Okay. I got distracted. Okay, we're trying to load an image. So let's just pull in this like image library for Rust. Image is equal to 0.7. We should be able to use this to load that picture that we got just downloaded. So move downloads wherever this one of these things must be the picture. Does it not save to downloads by default when I right click save as? Oops, not save link as. Save image as. Oh yeah, I'm just in the wrong folder. That explains why. So let's go to our stream start screen, save it here. And we'll just move star.jpg to test.jpg. The goal is to offset into texture reliably, so everything being erect is kind of nice, but I only worked with font atlases for freetype. Oh, interesting. So they can actually create an atlas for you. That's pretty interesting. Yeah, that's not how I was going to do it, but I will. Yeah, I'll look at that to see if that's. We'll see. Oh, atlases with freetype. Gotcha. Okay. So in main, let's just make one of the first things we do to load this image. I think it's image. I don't know. We have to read docs. Gotta read docs. Image reader open image.ping decode. This looks like what I want. So here we need to pull in this reader thing. They open the image. This is going to be test.ping, and these guys I'm just going to replace the unwraps for now because we're doing quick debug code. This guy is of type dynamic image. So what the hell is that? So this looks like, I see. So images could be backed by any of these guys, and we're gonna get one of them. So it's like print line debug of image. and just kind of see what that gets us. Holy dependencies. Holy. That's okay. So no such file or directory at line 9. Oh, it's because I typed pung, but it's a jpug. Let's try running again. Okay, that's a lot of 255s. If I look in here, can I actually see like the start of this thing? I guess we'll pipe it into less so we get the beginning. So this is an RGB8, which is probably fine. Okay. So can I like, I guess we'll match this guy and just, we'll only handle RGB8s for now because we don't really care. We'll say let image equal to image, match image, and we'll say please only be this type. So we'll say use image dynamic image, and we'll say dynamic image RGB8 is going to propagate the value, and anything else we'll just say please die unsupported image type. Okay, so now we have like this image, which is an image buffer with RGB pixels backed by a vector of bytes. And what we're going to do is we're going to load this into like a texture, they call it, in OpenGL world. So what we want is we need to like put the pixels on the GPU in a way that the GPU understands. And so I think, once again, I could be wrong here, but my understanding is that we use the word texture here to mean just like any picture, because we initially use them to be textures on things, but they could be anything, like any picture. And like that's what we end up with. Like you can like render to textures as well. But yeah, that's what we're trying to do. We're trying to get the thing on the GPU, and the way you do that is with the texture. So in your vertex or your fragment shader, you can say OpenGL texture. Learn OpenGL, perfect. So you can say in your fragment shader that one of the things that you want to pull in is an image. And you say uniform here is basically saying, hey, for all pixels, we're going to have the same value. So in means like there's going to be an input to this program that we're running on the GPU, and that's going to be different per pixel. But uniform means, hey, you set this before you call the program, before you call draw, and every single pixel will be called with this value. So here we put our texture in here, and you can like sample from this texture. I think it's with the, we can say that the, I guess this comes out to be a vec4 probably, and the color is you sample from the texture. So you say texture from our texture, and we can put in our normalized vert here, and that should say based off of like based off of where I am in what I'm rendering, find that pixel, the corresponding pixel in the texture, and like copy that over, and then we should be able to say color is just equal to that texture. I think. We'll see. And then what we have to do is we have to like bind that texture somehow. So probably before we get into our event loop, we will try to upload that texture. And I think it's, I can't remember the API name. So I'm just going to scroll through this guy really quick and see if I can find, do they have just like the full source somewhere? I don't really need them to walk me through it line by line. Activate texture, bind texture. So that's going to be important. But where do they like upload the picture? Texture image 2D, this is the one. So, okay, here they generate a texture. They bind the texture. Uniform is just a reference to where the local data is. Is that like local to the GPU though, right? I think that if you like allocate a vector and then put it, like create a texture from it, does that not end up in GPU memory? Like, and if I deallocate the vector, does that just like break? I'm actually not sure. Okay, so here they're generating the texture, binding the texture, and applying some wrapping parameters as well as some If I remember correctly, these min and mag filters are related to, I can't remember. Let's just look it up. Let's look it up. So min filter is texture minifying users used when the pixel being textured maps to an area greater than one texture element. There are 6 defined minifying functions. 2 of them are used the nearest of the 4 texture elements to compute the texture value. Oh, so this is related to bitmaps, which I guess are like these are like, I think, the fancy term for when you're like in a video game and you have like a lot of trees, you might see like a different version of the tree when it's far away versus when it's close. I guess trees is a bad example because the actual geometry is going to change. But like, say I have like this plane here. If I'm like way back here, you can't even see it, right? So using like a 4K texture on this thing would be like fucking stupid, right? So what they usually do, I think, is they make like different versions of the texture based like that you will load based off of how many pixels are visible. And so I think what this guy's talking about is they're saying, hey, when this is like related to if you're in between texture levels, how do you map which one to get to? I think minifying function when it greater than one texture one. I think, I'm not really sure. This is I'm a little out of my depth here. And then the mag filter, I assume, is something similar. Texture magnification function. Yeah, minification and magnification. I don't really know what those are, but related to bitmaps. So I guess we might have to set them even if we're not using that feature. I think I've seen in the past, if I don't set these, we just don't get the image. We can try it. Let's just try it and see what happens. So let's say we're going to create a texture. And then we're going to bind the texture. And I think we have to say that we're binding it as a 2D image texture. So that's texture 2D. I'm going to double check that actually. So this is a GL bind texture. Can we just like look at that? Target specifies to target which the texture is bound. Must be one of these many guys. And I don't. A texture first bound to 1D becomes a one-dimensional texture. Bound to 2D becomes a two-dimensional texture. So I guess when we create the texture, we're probably just allocating like a number that's, or like doing some sort of like, we're going to use this guy. And when we bind him, we're saying, hey, you're going to use this, like this concept is now a 2D concept, which will let us do things like index it in 2 dimensions, I guess. Just guessing. And then we eventually upload data to it with this text image 2D function. And this is when like the data actually gets put on there. And I guess like probably how the data is uploaded depends on like how it was bound or something. I'm just going to copy paste these APIs because I'm pretty sure they're important, but I don't really remember why. And then we'll just quickly convert these into like the glow versions of them. So text parameter I will turn into GL texture parameter I32. And so we can just do that for all these. And then anything that's like GL underscore here will get replaced with glow : is the way this works. They're mad about like U32 to I32 cast, so let's just patch those up really quick. And this guy we have to unwrap. Does this work? Oh, did I fuck something up? GL texture parameter I32. Text param. Yeah, it does seem like. Why? So this guy says he takes in the texture as part of him. So is that what this guy is? This guy's a native texture. And you typed unwarp. That'll do it. So this guy is a native texture. This guy takes in self texture, which I think is native texture, then parameter, then value. Oh, so I guess all of these first arguments should be texture. And then these guys should be as I32. Oopsies. As I32, like this. Okay. There's a good chance that they fucked something up in there, but we'll figure that out later. Then we upload the image using this guy. So we'll look at glow docs, which should be somewhere, and we'll look up text image 2D, and he's going to take in the target. So we have to kind of keep in mind that like both the glow version of the API and like the official version of the API. So we're going to look at GL text image 2D, and we'll just see if these guys match up. So he takes in the target level, internal format. Yeah, these are the same. Okay, so the target specifies the target texture. It must be GL texture 2D. All right. So this looks reasonable. Glow texture 2D. What's the second argument? Level. So this is, again, I think this is related to that like bitmap level distance number of pixels thing. And so we're just going to say we're always at level 0. Internal format specifies the number of components of the texture. It must be one of the base internal formats given in table 1. One of the size internal formats given in table 2. So I think there's two formats that are being passed in here we have to be careful about. One is like, what does our how do we want our texture to represent itself? Right, so if we want it to be to grayscale, we could only put in like one channel here. But that's different than the format of the data we're passing in. So this is like how we want to store it, and this is how it is stored before we get it. And you could match those up. You might have a reason to like swap them out. GL RGB seems fine for our case right now. The width is going to come from our image. So I think we should just be able to say image width. And the height, I think we should be able to say image height. Border, the value must be 0. Okay. Sure, why not? Okay, now this is where we have to be careful. This format is the format of the pixel data. So we know that we had RGB 8. I don't know if these are signed or unsigned. I think we saw, okay, we see a bunch of 255s in here, so it's unsigned. So here we say GL RGB is probably fine here. GL red, GL RGB, and then we specify what the type of each of those bytes is. So GL RGB and GL unsigned byte actually just happens to be right for us, right? Because it's an RGB image with 8-byte pixels. And now we just have to pass in the buffer. So I think that this ends up being image buffer data. Fine, we'll look at docs again. So this is an RGB image, which is an image buffer. And if we just want like the pixels underneath, is there like as raw returns the underlying container? That's probably what we want. As raw. Cannot find function GL text image 2D. So this is gl.texture image text image 2D like this. And he doesn't like this. This as raw returns the container, but we want this to be as a slice probably. Let's look at like option ampersand U8. So this would be sum. And I think that this guy said his underlying buffer was a vector, so we probably need to take a reference to him like this. Okay, and he's also complaining about some type shit, so as I32 probably is what I would do for all of these, I'm just guessing. Yeah. Okay. I don't need this extra ampersand in here, actually, it looks like. Okay, and so then all we have to do is make sure that we activate the texture. So if I remember correctly, if we run it right now, we probably won't see the picture. We actually just, okay, let's get rid of that fucking ginormous print. Where the fuck is that, this guy? Get the fuck out of there. Okay, so I made a mistake at normalized vert undeclared. Nice. I actually think somebody said that in chat a while ago and I just ignored them, but they were right. So we have vec2 normalized vert is equal to vert plus 1.0 over 2.0. Yeah, so nothing happens here, and I think the only reason for that is because we have to like set this uniform, right? We have a texture in here, and we have to like tell the program or tell OpenGL what texture we want to put here. And so I think you do that by saying GL active texture with glow texture 0. I think you say like, hey, don't worry, we have the first texture that you find that you're trying to use, we got you. And then by binding it, I think that sets it. I think. We'll double check here a second. No, I'm missing something. So let's just go back to this learn OpenGL page and copy paste anything that we haven't done. Bind texture. Did I not do that? Bind. Maybe I have to do that like down here or something before I draw. No. What am I missing? Okay. So they create their texture. They set their parameters, which we did notice that like why our parameters look different than theirs. They're taking in the texture. Which, what is this guy doing? Eventually he's going to turn into like GL texture parameter I. GL text parameter I. Why are those names different? Text. Oh, texture parameter and text parameter are just different words. So probably these guys should be text parameters. And these guys should go back to glow texture 2D. And texture 2D. And hopefully that gets us covered. Still nothing. So let's see. Let's think. What else could we try? Text parameter, text image. So that's what they do here. They say bind the texture, but they don't activate the texture yet. So maybe we'll do that down here. And we'll bind the texture again or something. Nope. Okay, let's just double check. So here we have these text parameters. They create the texture. They bind the texture. They set these text parameters for wrapping and repeating. Cool. And then they upload. So there's a chance that we made a mistake here and our like formats aren't matching, but otherwise we have texture 2D, RGB, we have the width and the height. Then they update their fragment shader to have a uniform in it, which we did. And then before they draw, they just bind the texture. Where did they activate it? I know, like, oh, here. Texture units. You probably wonder why the sampler 2D is uniform, blah, blah, blah. Activate the texture first before binding the texture. Here, they can set it manually. Okay, you can like say, I want my texture to be texture 0, but it should get that automatically if I remember correctly. Don't forget to use the shader before setting uniform. So I think we've done that. We've set somewhere, we've got our program, use program, yeah. God damn. What am I missing? So maybe we can double check in our fragment shader. It would be nice to know, I guess we can say, we know that our normalized verts are right. Are we calling the texture call right? Texture, our texture, text chord. Oh! Maybe our alpha is always 0, so here we can say RGB and alpha 1.0, just to double check, because it doesn't have alpha in the texture. I think it should end up being 1.0 by default, but vec for color, no. I'm trying to think, how do I want to debug this? Let's maybe see, can we check if we see anything. Like if we multiply this times like 1,000, 10,000, we still see nothing. So probably we're still just getting like zeros everywhere, which sounds a lot like we didn't bind it properly. Okay. Okay. I guess there's also a chance that the, let's like, how big is this image? Image width, image height. Target run. So we have a 1280 by 974 image, which should be fine. I don't see any reason that would be a problem. Because like sometimes the images are too small, and I've seen problems there. Okay, let's try reducing the complexity here a little bit. Let's get rid of like the image parsing stuff, and instead let's just manually generate a vector of ones, because then we'll know if we get anything in there. We will see how to say this. If we bind our texture correctly, we should see all white. So we'll say that we have like 255 U8 for fully white. And our size is going to be like, we'll call it like 1024 by 1024. So we'll say image data is this. Then when we create our texture, instead of trying to load from that image, we can say that we have our image is going to be red only, I think. So let's try to pull out what are allowed formats. So internal format has to be one of these guys, GL red. We'll say there's only red. Then we're going to say that the width is 1024, the height is 1024. And we're going to say that our data format is also red only, GL red, that's valid. And he is unsigned byte. And then we'll pass in the image data. The hopes here are that we will see all whites when we run. He's mad about something, so expected U32. Oh, I didn't finish typing out GL red here. Okay, and let's run it. Nope, he doesn't like that. So literal out of range for U8. Oh, I put a comma here instead of a semicolon. Okay, so we still see nothing. So that really like is indicating to me that our that we're just not binding correctly. So we should, like, there's something that we're not doing right before we draw that we should be. Maybe I have to bind, maybe I'll unbind the texture here, just in case someone else is fucking with it. Maybe. And run it. Nope, still nothing. What a pain in my ass. Because this was working, like, I did get an image on screen yesterday. Maybe what I will do is reference, like, I could cheat and I could look at the code I wrote yesterday to check. Because this is kind of like why I did this yesterday. Because it's like a pain in the ass when it goes wrong. What a pain in my ass. So, yeah, let's do that. I'm going to close this because I have to type in my password. And let's do this off screen really quick. One sec. What did I call this? I called this OpenGL test. And in here, I did the same shit where I found a texture and I created a texture. I set this unpack alignment, which was kind of interesting. I don't think I should need that. I bound the texture, and then I did text image 2D, and then I set the parameters. So maybe the order of binding, then setting parameters is important. And then down here, I did activate and bind the texture again before doing that. So I think let's just sorry, I'll cat source main, and I'll just copy paste this section from here before going back to our version. Was this? Oh, here we go. This is where we were. So the version that I had yesterday was more like this. And so let's try the same thing. Comment this out. This is what we did here. And we will try running this, except this time we were working with bitmap, so we'll copy paste this same image data shit here. Okay, probably run that. Oh, okay. So we've bisected. We are now seeing a red screen, which means that we're loading this like image data that we were trying to load correctly. And so I wonder if it's just related to these texture parameters, like not being set in the right spot. If I don't set these, I get the black screen. Yeah, so it's something related to this shit. I think it's not the pixel store, actually. I think it's more probably... Oh, I bet you... Okay, I'll bet you it's the bitmap linear. Like, here, when I copy-pasted, I called linear bitmap linear, and I'll bet you it's mapping to a bitmap level that just doesn't exist, and I probably should have just said linear or something, but we'll see. I think we're in an ad break, so I think almost done, so... We're back, baby. We're back. And, yeah, so I guess this, like, texture stuff, I would bet it's maybe related to the fact that I copy-pasted something that expected bitmaps, and it didn't. I probably copy-pasted these, like, texture parameters from somewhere different yesterday. So I'm curious about, like, which of these things are important and which ones are not. So... Like, if I enable these guys, these, like, texture wrapping ones, is that enough? No. If I disable these guys and turn on these min and mag filter ones, that seems to do it. So, what we had before was this, like, linear bitmap linear instead of when I wrote linear there. So let's just see if we can bisect and figure out, is that why? So if I take this mip map and I just replace this with linear, that does seem to fix it. So I should actually just find out I should read these again and figure what they do. So otherwise, I'll just hit this same fucking thing next time. Okay, so level of detail function is used when sampling the texture determines the texture should be minified. There are 6 defined minifying functions. 2 of them use either the nearest texture elements or a weighted average of multiple texture elements to compute the difference. So nearest will return the nearest, which is probably what we should be using, to be honest. We don't want to actually be interpolating, I bet. Linear returns the weighted average of the 4 texture elements that are closest to the specified texture coordinates. So how come there are 4? Oh, I guess because we're between pixels. Chooses nearest bitmap nearest, chooses the bitmap that most closely matches the size of the pixel being textured, and uses the GL nearest filter. Ah, okay. So these bitmap ones will go up and down between, like, resolutions, and these linear and nearest will just stay at, like, the current resolution. And so these 4 texture elements mean that, like, if I'm probably mapping from, like, something that's like this, right? Like, say, how do I draw this? I have a picture, right? And he's got a lot of pixels on him. And say I'm, like, these are, like, discretely quantized. And so say I have, like, this was, like, red, green, orange, and yellow. Say these are, like, the 4 pixels. And say, like, say that we're blowing this up into, like, a big thing. So we maybe actually have, like, 8 real pixels between these. If I'm, like, drawing, what color do I use to draw this? If I'm drawing, like, here, I want to, like, pick between the 4. If I'm drawing here, I might want to, like, pick, like, mostly red and orange, but also a little bit of green and yellow because I'm getting closer. And here I might want to pick like only red and orange, maybe like what's over here. And so I think that what this is saying is, as we move along here, how are we interpolating between the colors that we saw in our original image? And so that seems like what this min filter is. And mag filter is when the level of detail function sampling from the texture determines that the texture should be magnified. So probably one of these is for if it's getting smaller, and one of them is for if it's getting bigger, which makes sense. So maybe this is actually like, maybe my pixel is like this big instead of, so kind of like the opposite of what I drew here, actually. What I drew here was if it's getting, if I'm sampling too many times, and one of them is if I'm sampling too few times, right? Because my pixels are like this big or something. Okay, that makes sense. And so we just have to set these up. And probably if we want to set these to like, if we set them to nearest, we'll get like probably a less smooth image. We won't actually see the difference here, but I think that makes sense. Okay, let's try to load up the image again that we had downloaded. So instead of drawing this like red shit, let's pull up what we're doing again. This was an RGB image, and he had the image width and image height, and he was red, unsigned bytes, but now we were using was it image dot container as raw, I think was what we were looking for before. And these guys have to be as i32s. Okay. Okay, so that's something. It looks totally fucking wrong, right? But it is something. So it's because we claimed that the source thing was all red, which is just not true. It's RGB. Okay. Okay, so the colors are obviously fucked, right? But we're seeing at least that our like texture coordinates are approximately correct. Right, because where is my file manager? What's our file again? What's it supposed to look like? We want to go here. Not pictures. We want to go to work and stream start screen, and we want to look at this. Right, so like we're kind of seeing like the right shape. It looks like our green is just turning out blue. Our blue is turning out the correct color. So why would that be? Maybe our source image is like, sorry, let's look at this again. So this is what we are supposed to be looking at. And this is what we see. So one, we're flipped. But here we're seeing, I think we're only flipped vertically. So let's fix that first. So our fragment shader just wants to have the Y position be inverted. So we'll say normalized, I guess here we'll say normalized vert.y is equal to negative normalized vert.y. And that should flip it right side up. Cool. And it does just seem like green is blue? Like, what the fuck? And then these guys are just like a complete wrong color. Maybe we need more, maybe we got this parameter of like our internal format incorrect, or their internal format incorrect. If I say like RGB 8, does that behave better? So that's just fucked. But what if on our side I say that I want to store as RGB 8? Gotta run. Oh, it is just still fucked. What are we doing? So I wanted to make a stream intro screen that had like text rendered with OpenGL. And so we're just trying to figure out like we're spending all of our time, instead of actually doing that, with just opening an OpenGL context and drawing a picture to the screen. Could be unpack thing. Oh yeah, like this guy, like alignment, could be. We might as well throw that in there just to see. Nope. And we could also, we had some other parameters that we copy pasted before. Let's just undo and just double check. So we had the wrapping and the filtering. We'll just make sure that we had all of these guys. Fuck, did I just lose some data? Oh, that's so fucking annoying. I just accidentally undid a bunch of stuff and didn't... Lost my redo buffer. Because I typed something I didn't mean to. Well, alright. We'll just type it again. So we were... This is... Probably we were back in the state where we're seeing red. Yeah, probably here we were seeing the red again. And we'll just quickly bang that out again. That's annoying. So this was RGB. This was image width. This was image height. This was RGB. This was unsigned byte, and this was the image.as raw. And these guys had to be i32s. And I misspelled as raw. Okay, so we're back in this state, and then we had to flip this guy. So we were back in our fragment shader, and we flipped normalized vert y is equal to negative normalized vert y. Okay. We should be back in the same spot. I guess there's a chance. You know, we're not guaranteed that what we read is what we wanted to. So we could do like image right to something. Yeah, maybe some other color space than RGB. It seems possible. Because it does seem like the G is just totally broken. I guess we could also, we could construct a vector. Oh, BTW left the 10,000 thing in the share. You know what? That would probably do it. Thank you. You saved my life. Yeah, okay. So we just made a mistake and we're just multiplying our colors by a big number because I was like unsure about something earlier and I just left that in there. So it looks like we've like rendered an image reasonably. And that's pretty sick. And so now probably the next thing to do is to try to get a character rendered so that we can draw fonts on the screen. Cool. Thank you for the chatter who pointed that mistake out. That would have taken me a while to track down, probably. Okay. So the next thing to do is pull in the freetype library, and there we can pull in their like bindings for Rust, and we'll probably also have to grab a font that we want to use. So let's quickly download a TTF. Is this where I download it? This looks right. Download. For Mac and Linux, sure. And then let's look at that. What do we get from there? Hack. Okay, hack TTF. So I guess we'll just kind of like yoink this guy over here. And then we need to pull in the freetype library. So let's yoink him, freetype. And he's version 0.34.0, so we'll pull in freetype rs 0. Was it 3.4? Yeah, .0. And maybe we have to put an underscore instead of a... Oh, I just didn't put equals. That's why the syntax highlighting's broken. Cool. Cargo build. Let's see if this builds successfully, which it looks like it did. And so now we can probably, in our main, try to parse the font. So we will use these guys and we'll copy paste their example where they create a bitmap of this guy, which is exactly what we want. So we initialize the library, we get the glyph, and we say let glyph bitmap is equal to glyph bitmap. So no, what I'm like unsure of is if this is like the only way to use freetype. Because like theoretically, I could imagine that it would make more sense to like render the shape of the character. I like how they freetype RS hasn't paid attention to bumping depths and broke a common crate usage. What do you mean? I haven't like looked at this library at all. I just like googled how to use freetype, and this one looked the closest, like the most recently updated. And when I looked up freetype on Cargo, I saw like lower level bindings and higher level bindings. What like am I missing something that like makes this a bad library choice? They removed copy on some stuff because bitflags updated. Ah, I see. And so like then when you were copying stuff around, you probably just ended up with a bunch of like things that used to compile and no longer did because you bumped a dependency. Yeah, it's a pain in the ass. Part of the reason why I often opt to do things myself, because the dependency bumps, it's like it sucks when it's out of your control and then you get like fucked by a dependency. Like I honestly do. I'm of the opinion that if you pull in someone's dependency and then it breaks, you can't really like be mad at them because it's kind of on you for expecting anything better. You can't do this thing with syslibs, unfortunately. Why not? I would think that you should be able to generate your own C. Like, I think that if I just use the freetype library directly from C, I think that I would be able to just do all the same things. I think. I could be wrong, though. Could be wrong. Okay, we have a bitmap. Only one crate can link to syslib, so everyone should use the same thing. I'm not sure I'm following. Okay, let's render a character. We'll do G just for fun. And so we have our bitmap, and so we should be able to like replace just what we were doing with this picture, but with the bitmap that we have. So we can say Glyph bitmap width, or maybe it's Glyph width. No, that's not autocompleting correctly. Why? This guy is of type unknown. Why is that? Maybe because the language server doesn't know about the dependency yet, so we'll just restart it and hopefully that he'll resolve himself. And so I can hear my fans on my computer spinning. There we go. Okay, so that's a good sign. So this guy, oh, jump to definition, he returns a bitmap. So what's on that guy? Bitmap. Bitmap. So he has a width, a pitch. Okay, so that's something that's important to keep in mind, that the pitch and width could be different. So when we load it, we should load it as if the width is the pitch, and then in our sampling, we should take into account that difference. So here we can say Glyph bitmap pitch. Here we take Glyph bitmap height. No. Rows. I guess we don't know the data format of this guy, so we need to check that somehow. He has a pixel mode in here, which tells us if it's okay. So we're gonna have to check this, and because that will determine how we map on the OpenGL side. So let's just for now we'll just say println Glyph pixel type. Oh, you're saying that you should use the same freetype syslib everyone uses because there might be like name collision or whatever. I mean, like, should by some definition of should. But I don't know. You could always just create your own syscrate. I don't see any reason why not. That's just like bindings generation. I don't see like you could do that. They're saying that like you would have the same. Like, I guess this is just so that you would have the same underlying dependency. Oh, because if you have two crates that both try to link to libfoo, you're going to have two links against libfoo. I see. Yeah. I get what you're saying now. That makes sense. Okay, so let's try to get the glyph pixel type, and he will probably debug log him, and we'll say glyph bitmap dot, what was it, format type? I already forgot. Pixel mode. Pixel mode. So he doesn't like that because I haven't got brackets on here. And cannot open resource. So probably because I said, please use path to a font file, and we just didn't import the right thing. Okay, so we have pixel type gray. So that, I think, meant that it was an 8-bit bitmap, anti-alias glyph images. Each pixel is stored in 1 byte. Note the number of gray levels stored in num grays. Okay, so the input type is no longer RGB, it's R, or red. But unsigned byte is still reasonable. And then instead of image, we take in glyph bitmap. And probably there's some way to pull out the like underlying data. Buffer. Okay? Okay, so we just have this like absolutely fucked picture. And this is the reason why I had this like unpacked alignment thing in there the other day. So basically, like, by default, OpenGL assumes that your textures are going to be 4-byte aligned or something. There's like some number that is by default. And you have to like explicitly tell it like, hey, my bitmap of this character is like not that. Let's just double check. If we look at the actual data, can we say like printline glyph size is something by something else? And we'll say we have the bitmap width and the bitmap height. And I spelled width wrong again, as always. I spelled, wow, it's not height, it's rows. Yeah, so this is a 13 by 22, which is like very much not 4-byte aligned. And so it was like assuming that it could jump by 4s, but it had to jump by 1s, so we had to tell it that. But it does look like we have our thing. And so the last piece is, if in our fragment shader here, instead of taking the RGB value, we should just take the red value 3 times. I think you say vec3 from red, and I think that that will create a repeated value. I think, yeah, nice. Nice. Okay. Cool. So this is as far as I got off stream. And that's pretty funny. We're like an hour and a half in. That's like, I think that this took much longer when I did it yesterday. So it was already painful, but it was more painful if I hadn't done pre-stream prep. So okay, so we have glyphs, and now the question is how do we like render a string? And I think I saw in docs somewhere that like freetype should tell you when it renders a glyph how far you should advance your cursor after that. To bitmap, stroke, advance X, advance Y. Yeah, so this tells you, if I remember correctly, how far to move. Let's see, freetype advance X. Freetype render string. Oh no, wait, I think I actually had this learn OpenGL page on font running. This is exactly where I want to look. So yeah, they have the bitmap width, and somewhere, if they were to render a string, they would advance by advance. Advance our cursors for the next glyph. Note the advance is number of 1/64th pixels. So they shift it by 6 times the scale. Okay. I don't know why you would have an advance X and Y. I would assume that that Y should always be 0. Maybe we can take a look at that. Let's see what it says if we try to look at the character. So let's say glyph dot oh, Japanese is vertical. Yeah, that could be it. Yeah. That's a good point. Advance. Oh, maybe glyph dot advance. Didn't this say that there was an advance X API? Am I high? Am I high? Where I've lost it. We'll just reopen it. We'll say freetype docs.rs. And here, face, and then we said load glyph, and then we asked for the glyph, which gives us back a glyph slot, which is different than a glyph. What the fuck? So this is like kind of like a weird API too. It's weird to me that like we have a font face and we load a character and that's like a stateful change to the font face. Odd. And if I load many of these, like, do I have to load, then get the glyph back to back over and over again? What do these guys do on learn OpenGL? Assuming somewhere they load an X here. And they iterate over all characters, load the character, generate the texture, then upload the texture. I see. From face.glyph. Oh, I see. So every time you call load character, it replaces like the internal glyph inside. And okay, sure. Okay. So what is like a glyph slot? What the hell does that mean? A struct encapsulating the space for a glyph within a library. Convert a given glyph to a bitmap. It does so by inspecting the glyph image format. Get glyph gets the glyph object. Bitmap. The field uses bitmap descriptor when the font is set to glyph format bitmap. Advance is shorthand is depending on this guy. Okay, so probably this is just what I want. Let's print out advance. Print line this guy. And let's hope he has debug information. So say glyph advance. Try to run. What does he give me? Yeah, so he gives me a X amount that I think I saw someone say was in 64 pixels. With Y of 0, so that indicates like I was right that in the normal case you wouldn't advance Y. And I guess let's say we'll print X divided by 64.0 as a 32, and we'll see if that lines up with the size of the image approximately. 17, which for a 13 pixel wide picture, that seems reasonable if you want it, because you want to advance by a little more than the character width. So I think that kind of lines up. That seems like pretty reasonable. You need to advance top, left, and descent to draw string correctly. Advance top left. Yeah, I see. Like where top left is like probably the character itself has like a bounding box on him, and I have to offset somewhere relative to the size of the character. Probably. I think probably let's start by just doing the stupid thing, and then where we just advance by advance every time, and then we will find out why that looks like shit and fix it. So I think what probably we want to do is we want to like generate a font library, which like as like the same way that they're doing in this learn OpenGL example, where it looks like they're basically generating a texture per character, and then they're storing like the interesting information about it. Yeah, so we can do something like struct, what are we going to call this? Like font cache. I don't know if that's the right word for it, but like whatever. And inside him, he's going to have like a hash map or like character map. And he's going to map from a character, probably, to some sort of like cached character. Right? And inside him, he's going to have the texture, which I think we can call a glow native texture, I think. And he's also going to have like maybe the glyph metadata. So these guys are storing their width, height, and the top left and the advance. So that seems reasonable. So we'll store advance x as a I32 maybe. Advance y, top we'll call as left, top, and advance. Or we don't need advance y, we only need advance x, and then width, height. And oops, this is in the wrong spot. These are in the cached character. And here we need to use stood collections hash map. Okay, so we're gonna build our font cache. So maybe what we'll do is we'll have a function on here. It says like get character, and we are going to take in a character, and we're going to return a reference to a cached character. That seems reasonable. And depending on if the character is already in the cache or not, we're going to have to inject it. So we're going to say this is going to be a mutable reference to self. We're going to say self.character map entry of the character. And we're saying or insert with, and we're going to make a function here that generates all this stuff for us. So I guess when we create our library or our cache, we're going to have to initialize the library and load a font face and set our character size. I think all of that's going to be like static, so we'll just do that up front. And later we are certainly going to need some form of, like, we're probably going to want to change the character sizes later, but that's okay. Maybe, I don't know. Maybe we're going to have a font cache for a specific font size. That seems reasonable. When we get the character, we're going to say self face load character, which means that our font cache needs to have the font face, which I don't know what the type of that is yet. This is a face. So we'll just say in here, face, face. And probably we need to use freetype face, face. Cool. Then we also need the character map, which is going to be an empty hash map. Cool. Cool, 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 cool. Then when we get the character, so we're going to say, we're going to try to load the character. And then we're going to pull the glyph out of the character. We're going to, yeah, so we're just going to do all of this stuff. Which is self.face.glyph. And then we're going to have to pack this into a texture. So we're actually going to need to take a reference into our like GL stuff here. So we'll say GL is a glow context, I think is the right thing here. And so somewhere we like here our texture generation stuff. We'll just put all of that here. So we'll copy paste all this. Cool. Now we need an unsafe block here for GL shit. Fine. We return the texture from the GL block, and probably we want to unbind the texture when we're done here. So here we'll just say none real quick. We pull the texture of the unsafe block, and then we can return a cached character, and he has the texture. Advance x is glyph.advance.x. What else am I missing here? We have left is glyph.left. We have top, which I'm assuming is also going to be an AP on here. Oopsies. We need to put an as I32 in here. And then what else we're trying to store? The width is the glyph dot width. Am I high? Oh, glyph bitmap, I guess. Glyph bitmap width. And the height is the glyph bitmap rows. Okay. And then we have the entry. So this gives us what? A mutable reference to the value. So I think we can just bang that out. Okay, so it looks like this get character thing will work correctly. So let's replace all of this stuff we did before with our new font cache. We'll say let font cache is equal to font cache new, right? And we'll say let C is equal to font cache get character G. And we have to pass in our GL context now. So this is actually going to go way down here. Okay, we're going to comment out all this other stuff related to textures. And we're going to call this like G info or something. I don't know. We'll figure it out. And he passes in GL by reference. Cool. And now here we just have to make sure that we bind the texture. So here we're going to bindginfo.texture. And everything else should work the same. We need to throw a little mutable on this guy. And cargo run. And we should still see that G render, which is sick. And if we replace this guy with like an A, we should see an A render. That's still a G. So probably because in here I didn't actually pass the character in. C for character needs to end up here. There we go. Now we see an A. Cool. Now we put like an F. We see an F. Now these are all like scaled fucky wucky, so we'll have to fix that. But probably the next thing to do is like let's try to like render a how would we render a string? So we have our program, and our program just kind of renders a texture as like the full size of the screen. But probably we want each. Let's say that like this renders a specific character. We would have to like pass in the coordinates that we want to render at, and then maybe then we can like still sample the texture as like that whole thing. So I guess we would want, well, let's see, what do these like learn OpenGL guys do? Do they do it that way? That's how I would do it, but maybe they do something different. Yes, they have the location as part of their vertex shader. And then they have the texture coordinates are mapped separately. Sure, whatever. Yeah, okay. So we could say that in our case, we're gonna find the box that like the character belongs in, right? They're gonna say that like they have like a box size and where they should be relative to the cursor. And we'll kind of make a square in there and then render the whole picture on that square. Like the same way at the beginning we rendered our like plane to fit the whole screen. Instead, now we're going to resize it to map just to the shape of a character. Which probably means that we need a vertex buffer for each of these guys. We can still say that all of them are going to be a quad, so we don't have to have like separate vertex arrays, which I think are going to be different. We'll have a vertex buffer that we swap out for each of these guys, and I guess also we're going to have to set an offset in here. So first let's figure out how to like manually punch in one of these guys. So sorry, not manually punch in. Right now this is like manually hard coded in the shader, our like list of vertices, and we need to figure out how to like make them separate. So I think it's like something like GL create buffer. We'll say let vertex buffer is equal to this, and then we say GL bind buffer to glow vertex buffer. Well, let's look it up. All right, we're back. We're up and running. Okay, we're trying to figure out how do we bind that vertex buffer. So we're looking up the GL bind buffer API, probably. And this guy takes a target, which we want a vertex buffer, I assume. Which one of these are like texture, pixel, draw, indirect, array buffer? Probably array buffer. Let's see, learn OpenGL bind vertex buffer. I'm sure somewhere in here they're gonna tell me. Hello triangle, perfect. So they generate a buffer, they bind it as an array buffer, which is what I was guessing, and then they set the buffer data to data, perfect, okay. So we bind the buffer as a, what did we say it was? Array buffer. And we need to bind the vertex buffer. And, oops, this is actually supposed to be 32. Then I think somewhere in our shader, we say that we take in a position, cool. And I think we also have to tell someone that we want to use that as the input thing. So I think, where are we? Somewhere they say like, you set like the vertex attributes. Somewhere. Shader source, compile shader, attach shader, blah, 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 GL use program. Here we go. Go away, ad. So here they say basically you set up the like format of your data. So here if we have like vertices that are two floats, I think let's look up this like API for GL vertex attrib pointer. So this guy you say like index means like here when we pasted this guy he said like location equals 0. So here we're saying like we're gonna specify that this guy is the 0th thing. Size specifies the number of components per attribute. Must be 1, 2, 3, or 4. So I think in this case it's going to be 2 if we're going to do a vec2, I think. Type specifies what is in there, so we're going to use floats. Normalize specifies whether or not the fixed data points should be normalized, GL true, or converted directly as fixed point values, false when they are addressed. Stride is the offset between consecutive generic vertex attributes. So you might have like vertices packed with like other things. Like if you had 2 elements in here, you'd have like layout 1 and vec3 like other thing. Basically your stride would be 6 because if you have 6 items packed together, you'd have the first 3 going to this guy and the second 3 going to this guy. And the pointer is the first component of the first generic vertex attribute in the array. Okay, so I think 0. Yeah, that's okay. Cool. Cool. So if I was doing like the second thing, I would specify an offset of like of 12 bytes there for 3 floats. I think. We'll see. Okay. So now we bind the buffer. We have to specify our like thing in there. So we'll just kind of like throw these guys in here. So we'll say GL vertex attrib GL vertex attrib pointer F32, I guess. I don't know what that means. Oh, I'm not in my next show. Oh, I am. My autocomplete wasn't working there for some reason. Oh, because he's confused about like GL. He's confused about what goes in there. So give it a sec to figure out for my indexer to catch up. And what does this guy take? He takes in. Can I like jump to him? For some reason, my jump to definition on him isn't working. So we'll just look up the glow docs manually again. we have vertex attrib pointer f32. So what does this guy take? He takes index, size, data type, normalize. So like what are the, why does the, I don't understand why it's like a different API here for f32 and i32. I don't get it. Because I don't think that these guys have, am I like missing one of the many things there? Index size, 3, okay, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah, okay, I'm not seeing it. But that's really weird. Do these guys have like, oh, I pointer and L pointer, so that's probably why. So what are the different versions of these guys? I pointer, only integer types are accepted. Values are always left as integer values. Oh, okay. I see. So we'll just use the f32 version for now. And let's try to make a triangle. Let's try to make a triangle. So what do we do here? We say, we're going to, hold on. Bind our buffer. We're going to set our vertex data in there. So for now, our buffer is going to say like, let vertex data is equal to vec with maybe 0. Maybe we'll try to draw the same thing. Negative 1.0, 1.0, or negative 1, negative 1. Then we have negative 1, 1, 1, negative 1, and 1, 1. So these are our verts. This is going to be glow float, glow false. This is going to be, each thing is going to have 2 times the size of a float, so we're going to say 8, and the offset is going to be 0. We misspelled attrib, and he's saying that this guy has to be as, we'll just write false here. Okay. Then we enable him, GL enable vertex array attrib. What was it? Enable vertex attrib array. GL enable vertex attrib array, and the index is 0. Okay. Probably all of this stuff should come after our program is set up. And we still have to bind, we still have to like upload the data. So we'll say, is it Rust and OpenGL? Yeah, that's what we're working on right now. So we'll probably also have to upload this stuff. So it'll be like GL, where was that learn OpenGL thing? Somewhere in here, they must copy the vertices. GL buffer data. And we upload it as a U8 slice, and the target is glow array buffer again. The data is going to be vertex data, and the usage is going to be, I guess, glow static draw. I think these are like hints to the GPU driver for if they should be like if it expects the data to be overwritten and stuff. I think that's what that like a little hint is. Arguments are incorrect. So can I say buffer data? And it does have to be a U8 slice. So here I guess we have to cast this to a U8 slice. Can I? So I do it like std mem transmute. Like this. Does that work? I guess probably I should say vertex data as slice. And I wonder if that will do what I expect it to. Hopefully. Okay, so now I should be able to delete this like const code, this like hard-coded thing from my shader, and my vert should now just be a pause. This should be a vec2, and we'll say we'll call this vert. We'll call this like invert, and we'll say this is invert. So we have our invert copied to our outvert, and let's see if we get anything interesting there. No, so that's just not drawing, which isn't really that surprising. So maybe, let's see, what could we be missing here? Let's just double check that it's bound here. So we'll say bind buffer vertex buffer for GL, what is it? GL array buffer. Bind buffer, glow array buffer, some vertex buffer. So let's just try binding that again here, just double check. Still no. And is it possible that this array buffer thing didn't work? Or maybe it depends on like the order that we're supposed to do this guy. Also, these are wrong. This is saying his offset is 3, but it should be 2. So let's try fixing that. Still no dice. So we'll double check this guy. So here, does he have like his whole program written down somewhere just so I can like copy paste it and look? Okay, so he binds the buffer. He assigns buffer data. Then he sets the vertex attributes, enables them, uses the program, then draws a triangle. Okay, so do we do all those things? We create the buffer, we bind the buffer as an array buffer, we upload data using GL static draw and GL array buffer, so that's the same thing here. Then we set the attributes using 0 to GL float. So let's just double check those APIs. So size specifies the number of components per attribute. Must be 1, 2, 3, or 4. So we have 2, which is correct. The index is the index of the generic attribute to be modified. Great. So that's this guy. Cool. And then we have normalized as false, whatever. Stride specifies the offset between things. So if stride is 0, they're understood to be tightly packed. So we could probably put 0 in there. That seems reasonable. They are in fact tightly packed. Maybe you need to use the program before manipulating the buffer. That seems possible. Which we are doing here actually. We have the use program up here. Just double checking. We do just see nothing. Let's think. Let's just draw everything as, well, okay, actually, so our invert is this guy. And can we maybe draw everything as just white for now, just to make sure? So we'll say color is equal to vec4 1.0, just to make sure. So yeah, we are seeing nothing drawn. And I wonder how we can like debug this at all. Let's think. So here we create our buffer, bind the buffer, but blah, 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 upload it. And this is all related to the vertex array. So I wonder if like the order of buffer bind versus array bind makes sense or like is important. Oh, so here they also did all this before using the program in their example. So let's just double check that. Oops, we forgot to copy the vertex data over here. I am missing something for sure. Enable vertex attribute array. So that matches this 0. Okay. I think I'm probably at around the 2-hour mark, and my computer is in like kind of like a fucked up state anyways because of that like stream crash. So I think I'm gonna like do a little bit of experimentation off screen to see if I can get to this point, and then come back at this tomorrow. Thank you for watching. If you liked what you saw, I stream most days at around 1 or 2 p.m. Pacific time. There is a YouTube linked in the Twitch description for if you miss stream, or if you don't want to watch live for whatever, all VODs will be up on the YouTube. There's a GitHub link in the Twitch description where most of like the code that we write on the stream eventually ends up. Maybe not immediately, but at some point. There's also a Discord linked there. If you want to chat offline about whatever, announcements go in there too. Like I'll post when I'm streaming and like what the topic of the stream is going to be and stuff in there, and upload VODs. Yeah, if you're watching on YouTube and you want to come by and say hi, there is a Twitch link in the YouTube description. Otherwise, yeah, thanks for watching. Catch you guys in the next one. Bye!